Empirical formulas. In this video we are going to be learning about the empirical formula. Of course, we have important points to remember. The first important point to remember is EF, which is the symbol used to represent empirical formula. And then another important point to remember is the definition of empirical formula. So empirical formula is the formula which shows the lowest ratios of the different atoms in a compound. So meaning the empirical formula does not give the actual number of atoms in a given compound. It shows the lowest ratios or the simplest ratios of atoms present in a given compound. For example, you may be provided with some of the compounds. We just say, right, this is just a quick example. Write the empirical formula of the following compounds. Then we say A, C2H6, B, we say C6H6, C, we say N2H4, then D, we may say C5H10O5. Write the empirical formula of the mentioned compounds. Meaning what I have given you are the molecular compounds that are showing the actual number of atoms. Now we are talking about you writing the empirical formula which will show the simplest ratios of atoms present in each of the given compounds. So solutions. You are going to say A, the empirical formula equals C2H, or maybe let us be smart, we say the molecular formula here is C2H6, and then we are going to say meaning the empirical formula. Now you find the even number between the 6 and the 2, because when we are saying ratio we are dividing the numbers. We look for the even number which can go into 2 and 6, so it will be 2 itself. So we are going to say 2 into 2, it will be C, and 2 into 3 into 6, it will be 3, meaning this is the empirical the empirical formula, where the even number, we are saying the even number there is what? It's 2. That is very important. So this 2 is the even number, which when you multiply it with 3 will go back to 6, and then with 1 here will go back to 2. And then looking at C, or should I say B, the empirical formula will be CH. Why? Because the molecular formula is C6H6. So 6 into 6, it's 1. 6 into 6, it's 1. So here will be the answer. Then for C, N2H4, which is hydrazine, then molecular formula equals N2H4. So the empirical formula is going to be N2, where the value of N becomes 6. Becomes 2 as well here. Here the value of N is 6 in B. And then D, we have C5H10O5. So here we have pentose sugar. This pentose sugar, this is the molecular formula. And the empirical formula is going to be CH2O, and the value of N becomes 5. So mean this is the even number, which will show the actual number of atoms when you multiply it with the empirical formula. Okay, so this is actually the introduction. That's the meaning of the definition. The formula that shows the simplest ratios of atoms. So here, the simplest ratios, we have 1 carbon atom, 2 hydrogen atoms, and 1 oxygen atom. It is not showing the actual number of atoms present. It is showing the simplest or the lowest ratios of atoms. Now, you will find that these compounds, they are not going to give you the actual formula of the compound. They are just going to give you the percentage abundance of the elements that are present in that compound. For example, number 1, they are telling you, or number 1 you see here, they are telling you that find the empirical formula of a compound with the composition of 80. This is percentage is for copper, and 20% for sulfur. Meaning composition or percentage composition by mass of copper is 80%. And of sulfur is 20%. What is the empirical formula? I want you to understand an important point here. This percentage composition can be given as the percentage or as the mass, but the treatment is just the same. For example, question 1, they have given you the percentage composition. But in question 2, they have given you masses. If they wanted, they would have used what? They would have used 14% instead of 14 grams. Even here, if they want, they can use 80 grams. It's just the same. You need to understand that. Now, how do we calculate the percentage or should I say the empirical formula, when the percentages or masses are given. Number 1, you need to identify the elements present in a compound. So here the elements present in this compound, we are having copper. You write the symbol of the elements present in the compound, copper. We also have sulfur. These elements have percentages. So the contribution by mass to the empirical formula of copper is 80%, which can be 80 grams. And then sulfur is 20%, which can be 20 grams. Now, these percentages are equivalent to grams. Okay? Now, remember, my dear learners, that for us to find the number of atoms, the second step when you align your atoms like this is to find the number of moles of each element, because you need to know the quantity of copper. So we express the masses now to moles. How do we find the number of moles? We divide the mass given by molar mass. So you are going to say 80 grams. The relative atomic mass of copper is 64. You do the same here, you say 20 over sulfur, which is 32. What are you going to come up with? You come up with nothing else but the number of moles. So the number of moles here, when you divide, you find that it will be 1.25. 1.25. Here it will be 0.625. These are the number of moles. Of course, since we are finding the ratios, no problem even if you don't say more, because this is under empirical. Okay, so you just need to know that what we have calculated at this level are moles. Now we need to convert these moles to atoms. How do you convert these moles to atoms? You are going to divide these moles by the simplest number of mole answered here. So the simplest number of moles is actually sulfur, which is having 0.625. So you are going to divide both sides by 0.625, even here 0.625. Okay, you divide the number of moles by the simplest one. Then from here we are going to have here the answer will be 1, meaning in the empirical formula of sulfur we have just one atom of sulfur in the empirical formula of the compound. Here when you divide you find 2. So in this compound the simplest ratios of atoms are just 2 to 1. Therefore these are now number of atoms in the empirical formula. Therefore you are going to say empirical formula. This 2 is for copper, meaning in this compound empirical formula the number of atoms will be 2 of copper, and the sulfur just 1 we don't write. So this is the empirical formula. That is very, very important. We don't waste time on something simple. Question 2. They are saying 30 grams of silicon oxide contains 14 grams of silicon. Find the empirical formula of the compound. This 30 is actually the total mass of silicon oxide, but the mass of silicon in this compound is 14 grams, meaning the remaining part of the mass will be for what? For oxygen. So that is very important. Since this is silicon oxide, meaning this compound we have silicon and oxygen. So what are we going to do? Again, we are going to calculate. So we are saying we need to find first the mass of silicon, the mass of oxygen. So we are going to say oxygen equals 30 grams minus 14 grams. And the mass of oxygen now will be what? The mass of oxygen will be 16 grams. From this point, we know that the mass, the contribution by mass of oxygen to the total mass of silicon oxide is 16. And from here now, it's possible now we can allocate the masses according to the atoms, the way they appear in the compound. The first element is silicon. Silicon, we also have oxygen. Silicon, they are saying it has the mass of 14 grams. And here we have calculated that the total is 16. Where when you add this, you go back to 30. From here, what's the procedure? You can even pause the video. You try to solve this question. You are going to divide the masses by the relative atomic masses of the individual elements so that you can find the number of moles of each. So we are going to say mass, the mass is 14, so you are going to say 14 over the average atomic mass of silicon is actually 24, and here 16 grams over 16 grams. That's the average atomic mass of oxygen. And then when you divide here, you will find that it will be 1 more, and here it will be what? 0.5. These are the number of moles. You convert the number of moles to the number of atoms by dividing the number of moles by the simplest one, or the smallest one. And the smallest here is what? The smallest is 0.5. So you are going to say over 0.5 over 0.5. Here the answer will be 1. Here the answer will be what? It will be 2. Therefore, we are going to say that allocating or putting these atoms in the empirical formula, we are going to say empirical formula equals silicon, the number of atoms is 1 we don't write, so silicon, the number of atoms, and then oxygen, it's 2. So this is silicon dioxide. That's the empirical formula. What else? Do we have another question on empirical formulas? Let us do the last one. The last one, and then the fourth one will be your question. You can answer it on your own because I have guided a lot. An hydrated salt has the following percentage composition. Iron, we have 20.15%. Sulfur, we have 11.51%. Oxygen, we have 23.02%. And water, we have 45.32%. Find out its empirical formula. We understand, all of us, that an hydrated salt is the type of a salt that have water of crystallization. Meaning, that's the reason why they have given us the percentage of water in this salt. Very important. So again, we are going to allocate these atoms or the masses according to the elements. Let us align the elements. First of all, we have iron in the compound. We also have sulfur in a compound. We have oxygen in a compound. And then we have water in a compound. The mass by percentage of iron is 20.15%. And that of sulfur is 11.51%. That of oxygen is 23.02%. And that of water is 45.32%. We convert the masses given to us in form of percentages to number of moles. We are going to say 20.15 over the mass of iron is 56. That's the average atomic mass. And then that of sulfur will be 11.51 over 32. And that of oxygen will be 23.02 over 16. And that of water will be 45.32 over 18. When you find the relative molecular mass of water, it will be 18. When you divide the values here, you'll find that the number of moles will be, here it will be 0.34, and here it will be the same 0.34, and of oxygen we are going to have 1.44, and then water we are going to have 2.52. These are the number of moles, and then we are going to convert this number of moles to the number of atoms by dividing this by the lowest number of moles, which is 0.34. So each now over 0.34 over 0.34 over 0.34 over 0.34. Here the number of atoms now will be 1. Here the number of atoms 1. Here when you divide, the number will be 4. Here the number will be 7. Okay, so now you can now write the empirical formula since you know the number of atoms. Okay, so you are going to say the first element in this empirical formula is iron, And the number of atoms is 1, we don't write. Sulfur, it is also 1. Oxygen, it's 4. This water is hydrated, so you put a dot that there is 7 moles of water. This is how we are going to present our answer. This 7 is indicating the atoms, which means we have 7 times 2, it was supposed to be 14, and then 7 here. But we don't write this 7 in front of oxygen so that we can show that this 7 is also affecting hydrogen and oxygen. So we write it on the middle. That is very, very important. In as much as I am trying to help you, make sure that you subscribe and don't forget to understand the concepts. So this is where I am going to end with this video. Goodbye until next time.